So yeah, we wanted to talk a bit about a new series of webinars that we are starting to organize here within. Oh wow, okay, there we go. All right, great. Here within NFRC to help introduce some of our members to new sort of edge of research type of efforts that are going on in early stage technology development with respect to fenestration. So um, not only we want through these webinars to give you an opportunity to be able to learn about these, we want to give you the opportunity to potentially be able to interact with a lot of these early stage developers. And to be honest, I will say almost as important, possibly even more important, is the opportunity for them to interact with you and to learn, because many of these people are new to this field that have got some kind of exciting technology but still don't really have a complete grasp of what they're going to have to go through to make that product into reality. And that's where the connection, I think, between the early stage tech developers and NFRC can really give double benefits on either side. So we hope that this will begin to open some doors to further collaboration between you, some of your organizations, and some of these researchers. I know many NFRC members actually are already engaged with some of the people that we'll talk about, but we would like to see more of that engagement for the benefit not only of our members to learn about these early stage technologies and what may be impacting their business moving forward, but also to help the early stage developers understand what it means to have impact. So I think we can jump to the next slide, Jessica. So what we're putting together is a series of webinars. Series of webinars, as mentioned, that are going to be touching on a handful of developing areas in fenestration science. So this is the list of what we have got planned. Some of the formatting that we will do with this is, I think, still slightly up in the air, but we want to focus on technologies that are, as mentioned, really early stage, but also not too far away necessarily from the market, to where we can bring in individuals that can speak a bit about not only the technology side of things. We do have a very, very strong technical group here within NFRC. We enjoy learning new things and can certainly handle that kind of input, but then also people who can help give some perspective on the business side, kind of along the same lines of the same theme I was talking about earlier, of the science and the business sides really working together and learning from each other. So this presentation, we're going to go through really an overview. And it is going to be a quick flyby of some of the things that are going on in the relevant areas that were mentioned in the previous slide, to give you a bit of an update as to what is going to be in the pipeline. Many of the companies or research groups that we'll talk about will be participating in some of these webinars. Some may necessarily not, but if you do see something that's specifically of interest, please feel free to reach out. We'd be happy to make some connections even beyond the webinar. Or for that matter, if there's areas beyond this that you would like to see, please comment as well. So the areas we'll touch base on, as shown in the earlier slide. So dynamic windows, most of us are quite familiar with that space. Several different forms of highly insulating, and then energy generating windows. We're not going to go super deep on the last one because one of my team members here at NREL gave a lengthy presentation recently on photovoltaic glazing to this group. So we certainly can refer you to him for further questions beyond there. But next slide. All right, so now we're gonna move into a little bit of the tech side of the presentation here. So dynamic glass, this is something much of the NFRC membership is very much aware of. For those that may not be, there are really two different flavors that have been under development for the last several years. Electrochromic windows. These change their optical properties based on applying a small voltage. Normally, and as in the example shown here, this controls, at least today, visible light transmission. So it's more of a glare reduction technology that you can, again, control with a voltage. That allows you a lot of flexibility in how you control your product, but it also means that you've got to wire your windows and bring in additional trades to be able to get that done, which for some of the people in the industry has proved to be a little bit of a hurdle. The occupant control is also something that people kind of like. The way I like to tell the story is from an energy efficiency perspective. You really want to set the properties of the windows based on the building location to be done with it, but it turns out people want their buttons. So being able to really give them that control is good. The thermochromic side Similar type of concept at this point in time. The majority of technology that have been in development modulate visible light transmission, and they function based on temperature. So below a certain temperature, they're clear. Above a certain temperature, they darken. The installation can be greatly simplified. Cost can be reduced as well. There's no need to wire the windows. One maybe downside here is that you have to build, the exact, essentially the control strategy is defined by the materials, which have got to be customized for different locations, different orientations, and the like. Whereas in the case of an electrochromic, you make one product, ship it out there, deal with all the control situation offsite. And again, your occupant loses control in case of thermochromic. So next slide. Thank you. So some of the areas that are really kind of emerging in this area, and these are actually sort of outlined goals from DOE roadmap documents, research and development opportunity documents are what we call them now. Many of you may be familiar with that. Many of you I know commented on that when we needed a response. So we'd be happy to share that document with anybody who would like. But as I mentioned earlier, a lot of the technologies, the early stage technologies, just focused on visible light. There's become more and more interest in trying to take a look at whether we can use these materials in similar format, looking at near IR radiation. So essentially, to develop, or even into the mid IR, develop essentially a dynamic low E that could even be paired with the visible light transmission, to where you would have glare reduction with one product, and then the dynamic, solar heat gain from the low E type of responses as well. So that is one area that we'll talk a little bit about, where there's been some research that's going on. There's always interest in increasing the switching speeds. That's one thing with these technologies. They do tend to switch a little bit on the slow side. A neutral color is something we're after here as well, and there's groups working in that. The present technologies in the market certainly are moving in that direction. Many of the very early stage technologies have a distinct blue tint, which has seen good acceptance, but I've certainly seen cases where maybe that wasn't the case. And then obviously low haze, we got to see through it. The materials work. There's interest in new deposition methods that may bring down costs. That's really the biggest issue here. There's also some interesting work that's being proposed right now to be able to do this manufacturing in a decentralized format. That right now, everything is done in single plants by these companies. So that's something else to watch out for moving forward. Simplified structures, and then, as always, durability. That's a large part of what we do here at NREL with that. So if we could move on to the next slide. So where are we today with this? As mentioned, there's things out there right now. There's been well in excess of $2 billion invested in the development of this technology. That, in fact, View, one of the companies down at the bottom, that's $2 billion alone that they have taken in. They actually just recently went public through the NASDAQ exchange just within the last handful of weeks as well. Sage Electrochromics, many of you may be familiar with, they were acquired by Saint-Gobain a number of years back as well. So some very serious players, and like I say, with View now going public, and shortly behind them is Fenestration Technologies, which I know has done a lot of work with the side glass historically, that is looking, I think, very promising for what's coming forward. So there's installations all over the place with this right now. Costs do remain high. That is still a barrier for them. You still need your multiple trades. At present, there's still some limits in the color. Fenestration has got a good neutral tone. The others are certainly working in that direction as well. These technologies tend to be a little bit challenged from a privacy perspective, though. They really, the way we're doing this right now, the materials can't really get dark enough to hit what people are comfortable with, at least from a privacy application. The photo over here, just to demonstrate that there are real world installations. This is also one of my favorite stories, and I've probably told most of this group many times over. One of the things with dynamic glass is that we're always looking at benefits beyond just the energy savings. And so this is one of my favorite stories. This was a bank of windows near a bar in the Dallas-Fort Worth airport, where this glass was installed, and the bar found that their beer sales doubled over the course of a year, which I, again, always have fun that electrochromic glass makes you drink. Sometimes it may, with some of the things we've been through in the research areas, but this is just yet another benefit that we see. That, people are more comfortable, they stay longer, they have a longer conversation with this. So some of these things really are coming to fruition, even beyond the energy savings. So if we could pop to the next slide. So some emerging stuff that's going on here. Many of you, again, may be familiar. This is a company named Heliotrope Technologies out in the Bay Area. This came out of some technology that was developed at Berkeley by Delia Milren when she used to work at that organization. She has since moved to the University of Texas. This is one technology, probably the one that's been the furthest along in terms of trying to separate the IR from the visible in this particular case. And they've been able to create devices with, rather than a dark state and a light state, there is a state, the bright mode, as they say, that passes both your infrared and your visible, a cool mode, which passes the visible but not the infrared, and then the dark mode, which mutes both two at one time. Delia has continued to do some extremely good research in this area as well. So I would encourage you to check out links to both the company and her research laboratory are at the bottom of this slide. So next slide, Jess. Yes, another one here. This is a company that we at NREL actually have been working with for the last several years now. It was under the name Polyseed for a while. It's now called Glass Dynamics. That is basically a different approach. It removes some of the key device layers that are found in sort of the common solid state devices, the View, the Sage, the Kenestrel type approaches, and adds in some organic dyes, which allows a lot of flexibility. These materials are UV stable, so we expect to see good performance from them in that regard. But it also gives a whole lot of flexibility in terms of color tuning, which is, again, something that has been a bit of a challenge with some of the other approaches that we have got out there right now. Because their devices also simplify, their manufacturing becomes greatly simplified as well, which we believe is going to lead to some significant cost reductions in this particular area. So next slide, please. A third one, and I believe this may be our last here in the electrochromic space. This company is using a very different process. So I talked about the dyes for glass dynamics, and then the Sage View Kenestrel. That's actually a solid state metal oxide based technology. In this case, this is a newly forming company called Tint. It's coming out of work that was started at Stanford, and then moved to the University of Colorado at Boulder, where they are actually electroplating metal layers. Now, these are done in such a fashion that they don't produce a highly reflective surface. We've done some work with the highly reflective stuff within the laboratory here at NREL, but this area they're trying to stay away from that. This allows, I think, a handful of benefits in terms of improving the switching speed from this, the simplicity of fabrication. But then another big one here is that this one can actually reach a privacy type of level. I've never actually seen a specific metric for what defines privacy glass, but in this case, you can make that metal thick enough to where there's really no question that you won't be able to see through this. So this, again, developed, and this was actually under Mark LaFrance's program as well. Much of what you've seen, the glass dynamics, heliotrope, all of those have come out of the DOE program. This one was as well for several years and is, again, beginning to emerge as its own distinct company. So we will likely have some folks from this group speak to us as well. So next slide, please. Thermochromic. So this is an area where there's still quite a bit of active research. There have been a couple of products that have been put out into the market over the last handful of years, but we're focusing here at least on the research side of the organization. And this is looking at being able to do as mentioned, the thermochromic switching to where we no longer need wires. It can be a simplified installation. It can be integrated with a lot of different approaches. But does allow us dynamic control in the near IR. This certainly could be paired with other devices, with other visible light modulating devices as well. This is still pretty early stage research. We're using a material named vanadium dioxide, or just VO2. It, as a bulk material, doesn't really work very well. It has a temperature where this switching behavior between passing the infrared and reflecting it happens too high for really architectural type applications. But there was a gentleman named Sarvajit Banerjee at University of Buffalo, now at Texas A&M, who found that by making nanoparticles of these structures, you could actually bring that temperature down. The original work had it at about 68 C. More recently, they've done some work where they add a couple of extra components, really in this case, just one tungsten into that material, and find that it brings that temperature down to about 25 C from where they are. And we have friends at Argonne National Laboratory right here who are actually working on a way to scale up the synthesis of the nanoparticles. And there was another company that came out of the University of Buffalo named Dimian, who has been pursuing this area quite a bit. We've actually got a collaboration starting with the Texas A&M team that's likely going to involve them as well, hopefully. But we'll try to get somebody from this team in to speak with us about this as well. So next slide. All right, so we'll touch now on a handful of the different higher technologies. We can jump into the next slide beyond there. So, yeah, thanks. So many of these are going to be areas that some folks are familiar with. Some will probably be a little bit new. Some will be familiar, but not in their current form. So vacuum insulated glass is certainly an area where there's a lot going on. Many of us are well aware of that. Many of the people in this organization have been pursuing this for quite some time. There are some new things happening here. We are starting to see more technologies start to develop and merge into the market. We'll talk a little bit about that. Thin glass type applications for multi-pane. There is a lot of interest in this right now. A whole lot going on. There's going to be a lot going on under the DOE research program with this shortly as well. And then aerogel windows. I don't want to bust my punchline here, but you know the catch is now you can actually see through them, which tends to be a bit of a benefit in this market. But if we jump in next, we'll talk a little bit about VIG and what is going on there and the folks that we may bring in. Excellent. So, I'm sorry. Wow, I probably shouldn't have put both two of these slides in. My apologies on that, but this is just some of the needs here. So with VIG, you know, again, these are the DOE goals. So certainly want to decrease the cost. There's a lot of interest in metal to glass bonding, in particular around some flexible edge seal technologies that we are talking about, and then also process development for evacuation or actually processing in an evacuated type format. Aerogel, we want to get the haze down, get the manufacturing levels up to something that is reasonable. And then find different ways to process that. And then the thin glass work, there's a lot of interest there in how we handle that in safety glass type applications, maybe non-traditional ways of doing glass strengthening. There's some fun work that's going on at Oak Ridge, looking at some of that. And then automation of these processes. And that certainly has been done. We'll talk briefly about that, although I think many of you in this group have been working with that. And then also krypton gas filling. To try and maintain or to eliminate waste in that particular process. So if we pop to the next slide, we'll get into a little bit of the technology side. So vacuum insulated glass, it's here. It's been here for a while. The MST Pilkington folks have had this thing in the product for over 20 years at this point in time now. There are others. So we did see the introduction of a product from Guardian a handful of years back that they have continued to do some work on. I understand in a research level. I think many of you are aware that the Guardian backed down from that briefly. But Landglass, also a group out of China, is actively engaged with I think a few people here in the U.S. We can't say anything about who, but they have equipment to be able to manufacture big units that they are looking to sell into the U.S. There's multiple demonstration installations. Just an example, one from the Guardian work here at Eastern Michigan University that, from what I am told, has gone exceedingly well, and they're interested in seeing more of that. As mentioned, most major players are evaluating this or potentially developing partnerships. And another interesting twist that some may be aware of, but Panasonic has started to develop based actually on plasma display, old manufacturing lines that they had in Southeast Asia that are being repurposed for this. So there's continuing momentum behind this coming forward. So I think we'll see something fairly soon. If we hop to the next slide. Breaking another slide set out as an emerging technology, well, these are the research challenges, or at least a couple of them. There's a lot with VIG, but two that we feature with some of the groups we're talking about here. One is durability. Nature abhors a vacuum, as most of us are quite aware. So being able to maintain the low pressure between the glass lights that's required to get the performance is probably the biggest challenge that we've got within this particular area. Many people have been working on this. We're actually doing some work at NREL in the durability program, looking at this along with collaborators in a few different organizations, including the University of Sydney. And then a second one that has been actually the subject of a lot of interesting discussions, really just even in the last handful of weeks, is the ability of these units to withstand thermal stress. So in the case where you have hot temperature on one side, cold temperature on the other side, you have one glass light wants to expand, the other one wants to contract. That forces those edges to want to really turn, which then can cause, I should say, the units to bow. And this phenomenon is known. The early VIG work, many of you may be aware, was done at the University of Sydney by Richard Collins. We're working now with Cenk Koser, who is leading that group down there at this point in time. They certainly have seen this, confirm it. There have been some certain approaches that have been taken for products that are on the market that really don't appear to be seeing this bowing effect. So that's something I think at a research level we're really trying to understand. But there's other companies that are trying to find a way to potentially circumvent it at the same time. So there's a lot of open questions as to what this flexing means, what's driving it, when we see it, when we don't, and why it does or does not matter. So that's going to be an area we'll be focusing for a while. But if we could pop to the next slide. So as mentioned briefly, so the early stage technology, the first demonstration at Sydney was based on a rigid, essentially glass solder edge seal shown here on the left. These are, sorry if these are a little bit difficult to see, these were from some of the original papers from the Sydney group. More recently, there's been developments in trying to take a look at creating a flexible edge seal, really to deal with that differential thermal expansion. And some companies are taking maybe sort of a bellows type approach shown in the top figure here. Others are approaching more of a three-dimensional structure because they believe the glass lights will potentially need to be able to move three-dimensionally rather than just in one. So if we could pop over to the next slide, we'll talk a little bit about a couple of the players in this space. V-Glass is a company that many of you will likely be well aware of. Pete Pettit, shown there on the right, has been a good friend of many of us, to be honest with you, for a number of years now, and has been working on this for quite a while. So he has got one flexible metal edge seal that he has been working on. We don't have a lot of detail about that, but we do know that he is doing very well with what he is doing so far. Has done extremely well with funding from the DOE program. And is hoping to see that move forward and move it into some partnership agreements in the near future. Astrovac Glass is technically a new company with an older technology. So many of you might have been aware, if you were tracking this area, of a company named Eversealed Windows. The founder of that company passed away a number of years ago. Astrovac is sort of the rebirth after a new group of investors purchased the technology from the original CEO's family. So this is one that does work on a three-dimensional flexible edge seal that they believe will give a little bit more leeway in terms of what we can and can't get away with these particular, basically with VIG in terms of long-term durability. So next slide, please. And on the research side, so this one, I should, to be honest with you, let Mahabir speak about this, and I think we will as we move forward going down. But there's been some good work at Oak Ridge in terms of employing additive manufacturing techniques, laser sealing, and then also, as I mentioned, alluded to very briefly, some novel glass strengthening processes out there that may help in this particular area. I would definitely encourage you to reach out to Mahabir to learn more about this particular effort, because there's a lot of very fun, interesting things. And I believe I left a slide out here as well. There's another project at the University of Maryland that's also under the DOE program that we will likely try to bring that team in as well. They've got a little different way of doing some things with the glass that eliminates some of the need for support pillars between the two lights. So those are required to keep the glass from collapsing on itself when it's under vacuum. So next slide, please. Okay, aerogel. So we're going to go through this a little bit briefly. This is going to be a little bit of more a sciencey space here. So this is a material that many of you may very well be aware of. You've probably seen the two pictures on the left here. that are shown as they're commonly shown for aerogels. They're extremely good insulating materials. They essentially are extremely, very, very porous, small networks of some kind of a solid state material, normally a metal oxide, often a silicon oxide. But as you can see on the left, they're extremely light. They're extremely thermal resistant. You can see the flower being able to be protected from the Bunsen burner. Those are the demos you've probably seen, but you also notice when you look at those, you see the early attempts at the windows. These simply aren't going to work. The haze in the materials are just simply too much for this type of an application. That's where the breakthroughs have been in the last handful of years in terms of moving these technologies over into something that is optically transparent. And there's several people that have done that. So I just show here Aspen Aerogels. It's a company up in Massachusetts who is actually really doing very well right now in large-scale manufacturing of aerogels, often for opaque insulation, and I believe also in some aerospace applications as well. But they have done some work in the window space beyond that, although we're not going to say too much about that here. So if we could pop to the next slide. Okay, so this is one example, and it's kind of a fun one. So there's been really good work done here at the University of Colorado at Boulder. Given where we are at NREL, obviously we interact a lot with the CU team, so that is showing up here a little bit. There's also really good work that's been going on at Virginia Tech and Arizona State. I'm sorry, not Virginia Tech, Virginia Commonwealth in Richmond, and at Arizona State as well. We may very well try and pull some of those groups in. What's fun with this one is that these folks are using a bio-based material. They actually use waste from breweries in Boulder to create these nanocellulose material structures. This is based on a liquid crystal type technology that this group is really world experts in, to create these very, very low thermal transport materials that also are highly transparent and also flexible. So you can see, I mean, the optical data we show you there. So we have great transmission, low haze, excellent color rendering. The image on the right, top right here, shows you a piece of the film actually installed in a building on the campus there at Boulder. It's not the entire, so the red area that you see there is showing you where the edges of the film are, showing that we do have excellent optical performance from these. They have been able to scale this up now to full meter by meter sizes as shown below, and then also over into a flexible roll type format. This was coming out of the ARPA-E SHIELD program that some of you may have been familiar with. It was about retrofitting commercial glass, it's single pane specifically, and looking to see whether or not they're going to simply apply the film. That's one approach this team is taking. They're looking at a handful of others for IGU integration moving forward. We'll be doing some work with them on durability shortly. So can we pop to the next slide? Thin glass. So I'm going to apologize up front. This one's going to look like a little bit of a commercial for Alpine Windows. I had them come and speak at a meeting that we had here at NREL a couple of years ago, and so some of these slides are left over from there. But again, many of you are looking at this technology right now. It's a very exciting time to be doing that. We've known about this technology for a number of years now. It looks like there might be some traction starting to move forward, that this is actually going to go out by quite a bit. Most of you, I think, are well aware of this, but the basic idea is to be able to use a very thin glass light as a center pane in a multi-pane type construction, or center panes in some cases. Alpine has demonstrated and NFRC certified up to an R10 window using these type of approaches. That, I believe, was a quad pane with multiple, two thin glass lights in the middle and then multiple low E coatings throughout, but have also been able to work with this at relatively nice scale and at a few different sizes as shown below. So next slide, please. Great. So manufacturing, something that we talked about earlier, and again, others may be chasing this as well, but we certainly know from Alpine, they have been able to run the thin glass successfully on high capacity vertical IG lines. They have been ecstatic about what they have seen in terms of processability of this product. I know I spoke with Brad Began, their CEO, just last week about this. They're also exploring some secondary markets with secondary windows, window inserts, using some of the thin glass technologies, in some cases multi-pane We've actually been doing some field validation studies with them on that, as have some of the other labs. In fact, I think the next slide, if you don't mind jumping, will show you a little bit of that. Yes, so several field installations of this, drop-in units that were able to go in. This was done in California. I'm not certain who. I know that PNL has been doing a lot of this. Berkeley has been involved. And then we've done some projects here with them locally and have a couple of others planned further. So we're starting to see, again, interest in this. There are some things going on right now too in terms of trying to take this approach and integrate it with dynamic glazing or photovoltaic glazing. There's a long-standing goal of the DOE program has been trying to combine dynamic solar heat gain with really high R, and this could be one of the few vehicles to go about doing that. So there's several efforts that are in a research phase right now that are looking at that really specifically as a vehicle to move this in. So maybe the next slide. Energy generating windows. So again, as mentioned earlier, all of this is a flyby. So this is going to be a fairly quick run through just to get you up to speed on this. You know, the basic story here is if we go take a look at high-rise construction, office buildings in downtown areas, integrating solar with that, there's very little roof area, there's a whole lot of floor space, we got a problem. Well, can we put these things on the vertical facade? The answer is absolutely yes, but then we start dealing with a bit of a problem. You notice on the bottom right, you can't see through the thing. So there are areas where that's applicable, spandrel type applications, et cetera, where we can take that, but we're also interested in using more of the building skin, but we also want to be able to see outside. So we're doing work right now in a few different places to be able to create solar cells that allow that. There's a handful of different approaches. If you jump to the next slide, Jessica. Again, Lance Wheeler, I think, walked a lot of this group through this, but just to touch base, I mean, you have this problem of you want to harvest the sun, but you want to see it. What do? So there's certainly parts of the solar spectrum that are outside of visible light, the infrared, the UV. We know this very well. You can go get those. Turns out that's a portion of the energy that's available, but it's not necessarily most of it. So the real energy that's mostly available is out there in the visible spectrum. So the approaches people are taking are either you stay away from visible, which is shown with the invisible absorbers here on the right, and go with a semi-transparent solar cell absorber material. In that case, you're essentially making something so thin that you still can see through it, but get some energy generation. And there are some trade-offs with that. You're not really getting all the energy, but you want to see. So there you go. There's also been some very interesting work, and this is coming out of Princeton. That's the one shown here, kind of the second one in from the right, where people have started to integrate some of these technologies with other type approaches. So this is a group at Princeton, I may have mentioned a second ago, that has been working in this area. They formed a new company called Andaluca that is just really starting to emerge, and they're using these UV range transparent solar cells basically to power an electrochromic. So you've got everything on board. There's limited need to be able to wire your window into the building structure, et cetera, potentially several benefits from that. But so these are two key ways that people are able to get across from that. And if we hop over to the next slide, I think we'll start talking about who's doing this. Yes, okay, great. So this is happening. This is not, some of this sounds like science fiction, transparent solar cells, woo, turns out it's real. And there are things that are moving right now. So these are just a handful of companies that are in this area. There are some beyond this. Next Energy Devices is one that's using an organic material to create a semi-transparent device. This allows them to do solution-based coating to simplify and bring costs down. Anyway, that one is doing really quite well with where that is. And then the right up here, Ubiquitous Energy, this is another fully transparent. So two of the things you saw on the earlier slide there, the UV and the near IR, were papers by a gentleman named Richard Lunt. So that's actually Richard with his device that's shown in the picture here for Ubiquitous. They have done very well. They started up in Michigan. They've actually got into the Bay Area at this point and are partnered with some of you. So in fact, the image on the right here with the Ubiquitous logo is an install at Pilkington Research Center in Toledo. So again, these things are real. We're actually working right now on installs with Next and then this bottom company, Ubiquity, also. So these things are starting to emerge. There are I'm not going to call them, they're not really released products yet. I'm not certain of Ubiquitous status with that, but we are starting to get field data. We are actually starting to make units that can be installed. Ubiquity, down at the bottom, takes a very different approach. So as mentioned earlier, the two folks up top, they're actually building a full solar cell. You've got to deal with getting everything transparent and all the fun that comes with that as a material scientist, which is fun, but can be expensive and take a long time. The bottom, with Ubiquity, what they're doing is they're using a material called quantum dots that absorb energy. They're absorbing, I believe, in the infrared in their case, or no, I'm sorry, in the UV, and then they'll re-emit a different wavelength of light, and that wavelength of light is redirected to the edge. So and the edge has just a small PV cell. So that's what's shown schematically here on the left side of the photo for Ubiquity, and then the green glass image you can see. This is called a luminescent solar concentrator, where the light comes in and then gets re-emitted out the edges, is what they're doing. And that allows you, to be honest, to really simplify things quite a lot. You don't have to build the entire device on the glass itself. You can just simply, in fact, what they are doing is add these things into PVB or some other common laminate material, and then epoxy some cheap silicon solar cells onto the edge of the glass. So that's another one that's kind of fun, and it's got a bit of an interesting twist. So if we could pop over to the next slide, I think I've got, okay, yeah. So this is certainly in the research stage, and this was also part of the earlier NFRC conversation, so I don't want to go too crazy with this, but I do have to give my guy Lance a bit of a plug here. This was done by Lance Wheeler, one of our NREL scientists, where we actually accidentally ran into a solar cell material that had a thermochromic effect. He coated a piece of glass with his material, put it on a hot plate, it turned black, that's great, pulled it off to let it cool, came back 10 minutes later and found a clear piece of glass and was confused. So we ended up moving from there into this space. What's interesting about this is that it really circumvents some of the problem that we told you about earlier, where you want a good solar cell, but you want to see through it. So in this case, because the material itself can actually bounce back and forth between being clear glass or darkened glass, that in this case actually is an exceptionally good solar cell performer. This is a material called the perovskite. If you look in the solar literature, that perovskite is a much more general term, but it's a certain class of materials in the solar program that are very easy to process, can be extremely low cost with that, and are also a very high performance. His initial device, I think, was a 10% conversion efficiency. I believe perovskites are pushing 20 something right now. Whether this technology will get there, I don't know. But anyway, so that gives, I think this is the last technical slide, but as mentioned, we wanted to give just a really quick flyby. We do have some times for some Q&A if there's interest in this, but just to let you know a little bit of a flavor in some of the people that we're potentially going to be bringing in. We'd like to remind everybody about the webinars that we have got planned. These should be very easy for you to join. And then importantly, in the Atlanta meeting, which we are expecting, we will all be in person. We're certainly hoping we will. We expect to bring a lot of these people in to that, to participate in some kind of a panel discussion. And as Miss said, meet you. You get a chance to learn from them, they get a chance to learn from you. So I think, thank you for everybody's attention. That should be the final slide. And I think we do have a little time. I didn't quite catch exactly when we started, Jessica, so I think we do have some time for questions.
Yes, we do.
Yes.
Michelle's going to read those questions. Go, Michelle?
Oh, great.
Yes, hi. Thanks, Rob. So the first one is for, it says for large spans of 1.7 millimeter glass, how are the safety glass requirements addressed?
So that I think, to the best of my knowledge, is still very much an open question. I have not heard a good answer to that at this point from what I have seen. Some of the people that I do know that are working with the thin glass, and it's not all just Alpen, have been extremely happy with the response that they have seen to wind load testing and the like, that the products appear to be more robust than one might think. That having been said, again, I think it's still very much an open question. It's actually one I think we would like to be doing a little bit of work on within some of the durability programs at NREL, and Mahavir's got some new equipment as well over there that may help us take a look at that as well.
Okay, great. And the next question is, have the thin triple windows been tested for structural performance?
So, well, yes, there has been some the folks that have, and I was more or less alluding to that a second ago, that there are people who have certainly done that, and the information I am getting is that, as I said a second ago, they've been quite happy with the results. We'll see where that goes. Certainly, as more data begins to emerge, that is still a big question with that technology. But I've been encouraged, or at least the people that I know that have been looking at it have been encouraged with what they've seen so far.
Okay, and a couple more. So how can manufacturers get involved with NREL on some of this research? Are there specific programs that they should be looking into?
Potentially, yes, but I also want to call out, this is not just NREL. So there's stuff that's peppered in here that's LBL, there's stuff that's Oak Ridge as well. And Argon was even in there. So I think it's more the general program. And in that case, the first person to go talk to is Mark LaFrance. I believe most all of us know. If you don't, somebody can most certainly introduce you if he doesn't do it himself first. So that those opportunities are certainly there. There's going to be a handful of opportunities coming specifically for companies to work with the labs that Mark is actually working with us right now to kind of scope out. I'm going to say us again. That's all of the laboratories. There are some specific programs to the individual laboratories. The one that's at NREL is a technology incubator that we oversee. It's actually funded by Wells Fargo that allows companies to come in. Wells Fargo essentially pays the bill for us to do a project on their behalf. I should have actually mentioned that earlier. You may have seen several slides that had a logo that said IN2 in the bottom right. Those are projects that we've been doing under those programs. But again, there's similar efforts at the other labs. So Berkeley has got a really exceptional program, and I've got some friends of mine from here in the Denver area that have gone and participated in that as well, called Cyclotron Road. That's very much focused on early stage startup type work. And then I don't, if Mahavir is on, I cannot recall the name, but there is a program over at Oak Ridge, similar, and for that matter, one at Argonne. So all of the laboratories have got efforts similar to this that are out there. And I think if you just reach out to them, reach out to Mark, we certainly can hook you up with those.
Okay, and one more just came in, and it's, are the thin units at Alpin vented between the air spaces?
I'm going to have to let them handle that one.
Okay, great. And then the last one is, are there basic documents available to understand the technologies and how it can be implemented? Is there a website or a place that you want to send folks, aside from our emerging technology webinar series, but is there a place where people can go to read documents to understand the technology and how it can be implemented?
That actually is interesting. There's been some work. We helped the LBL folks out last year, I think, with doing something similar to that on electrochromic technologies. I don't know how much, because there was a series. Luis Fernandez was the gentleman that was putting it together out there. There was a series of more or less educational videos that were targeting kind of what you're talking about right there. And it's been a little while since I've taken a look at those. So I would look at LBL to see whether or not, and Luis Fernandez, again, is the name to check, and see whether or not there may be something further out there. I think, to be honest with you, any of us would be more than happy to talk. I certainly am. I often am tough to shut up when I get on these topics. So yeah, I don't know of anything. I know there's been some attempts to do that. Certainly would not be a bad thing to do.
Okay, great. And if there are no more questions, thanks for your time, Rob, and I'll turn it back to Jess.
Sure. Sounds good. Thank you.